Welcome to the lectures on database management system. In the previous lecture, we talked about the history of DBMS and the importance of DBMS for an organization. In this lecture, we talk about the earlier implementation of databases. Even before the term of database, people used to store data in terms of files with the limited knowledge of programming and the available resources of memory and the other amenities. In the olden days, people used to store data in terms of files. Suppose in an organization, if you want to store the details of, say, products and customers, then we have to open the files, two different files, one for products and one for customers, and one for employees. So like that, for each of the components, they have to open the files, and whenever data is generated, they have to open the file, write corresponding data in the file, and close it. And whenever they want to operate any query on the files, suppose if they want to know how many products are being sold in a particular region, then they have to open that file and read the contents of the file throughout the file, and they have to identify the suitable region, products from the suitable region, and they have to compute the total sales and all these things through a programming language only, because there is written raw in a particular file. So this is what is involved in file management system in the earlier days. Then it looks fine when the data is very less and the complexity of the data is very less. But as the data is growing exponentially and the data is increasing, this system seems to be very inefficient. Let us see what are the inefficiencies of file system in a nutshell. The first one is data redundancy. Suppose if I store some information in 2-3 files, at least part of the information in 2-3 files, then data is redundant there. What is the impact of that? Suppose if I update one particular data in one file, and if I forgot to update the same data in another file, then that's going to create problems, because if I try to get the answers, I may get two different answers. So inconsistency is generated. So duplication of data is resulting in inconsistency of the data, and in file systems, it's not simple to manage this. And another thing is difficulty in accessing the data, because we need to write complex code and we need to write programs for each task that we want to operate on the file. Suppose if I want to have a query like how much the total sales in a particular month, then I have to write a query for that. I have to write a program for that, linking all the files which are corresponding data is present. Like that, for every query, I have to write a new program. I have to start writing a new program. And the queries may be coming at different paces. So every time I have to write a program for that. So it's very difficult in accessing the data. And sometimes what happens is the required data in a file may be at the end. You have to access the entire file and reach there and get the data. Sometimes the data may be at the beginning. So it all depends on the data that we're asking. And not only that, bringing the entire file into the buffer is also a problem, because the size of the file grows, then the buffer, holding that file in the buffer also becomes difficult. So all these such aspects of accessing the files and simultaneously accessing several files is also a big task. And the third one important thing is integrity problems. So whatever data that is written in the file, how do you check the integrity of the data or authenticity of the data? Whether the correct data is being generated, is written or not, any check on that, there's no check. Even if you want to implement such kind of integrity, you have to write a very complex code for that. Right. So such kind of problems do exist in file systems. Another drawback of file systems is atomicity of updates. Whenever an update is done, first thing is that update has to be carried out wherever that multiple copies appears. The second issue is, how do you ensure that the update is complete? Whether it is left in the middle, the closure of the file is it because of the completion of the details of the updates or because of the failure? There's no checking mechanism for that. So atomicity of updates is a major issue here. Not only that, the concurrent access of the data. Suppose customer data is there of a particular organization, then several departments wants to operate simultaneously on the same file, then create problems. We need to have a mechanism to provide that. In file systems, it's very difficult to provide concurrent access or simultaneous access. Another issue is security problem. How do you protect the data in a file? The only mechanism available is a password protection. But every time password has to be used to open the file and read the contents and again store. So sharing the passwords is another issue to provide the security. It's not that simple. Apart from passwords, there is no protection mechanism to save the data in a file. So all these things are the disadvantages of some of the disadvantages of the file systems. And surely when data is very less, it may work fine, but the data grows. As the data grows, file systems are by no way useful to maintain the data. So there should be, it identifies the necessity to have a comprehensive mechanism to store the data securely and to take care of the accuracy of the data as well. So we need a database management system which can take care of all these things. So now we observe that file system is not going to work if data is large, and there is a need to have a comprehensive mechanism. The answer to this is a software, dedicated software written with a collected set of principles to tackle the insertion of the data, processing of the data, and querying of the data. That is called Database Management System Software, DBMS. So what are the advantages of having such a software, and what are the provisions that it can have to the entire system? Let us see some of them here. The first one is the efficient data access. If we have a clear-cut mechanism to store the data, and then we can pinpointedly identify where the data is located, and we can retrieve the data whenever it is required. We can efficiently access the data. So it depends on the model that we use to store the data. That is one way. Another way is storing of the data may not always be in the same hard disk where the software is connected or residing. So sometimes we may store the data on the external hard disks, and our system DBMS should be able to tackle, will get to fetch the data from wherever they are stored in the external hard disks. So the DBMS will take care of that. So there's a efficient access will be provided in terms of the data stored on external disks as well. The second most important thing is data independence. If we create a software for that, the end users who are using that software should be unaware of the logical structure in which we have stored the data. That is called the logical independence. That means the model that we have used to store the data is not known to the end users. So even if we make minor modifications to the logical structure of the data, the end user is unaware of it. That is called logical independence. That is one of the major advantages of any DBMS. Not only that, physical independence also. Suppose at a particular location, there is a problem to store the data on a particular hard disk. If you want to replace that, even if I change the location of the data from one hard disk to another hard disk, the end user should be unaware of it. So that physical independence with respect to the data, where it is stored, how it is stored physically, should not be known to the end user, and the end user should be unaware of it. That kind of logical as well as physical independence can be achieved through a database management system. And integrated security. There is a way of many ways of providing security as well as integrate the data. Even when you are entering the data into the DBMS, we can have a control over the data, how it is to be entered. Whether we are actually entering the exact data or not, we can have a controlling mechanism for that. When it comes to the integrity and security, database management system provides a variety of mechanisms to enforce the integrity of the data. Right from the entry of the data, it checks whether the correct data is being entered or not with respect to a specification given. Similarly, we can enforce variety of constraints or collection of data as well. When it comes to the security, on the same data, we can have access controls. We can provide access controls to different users of the database at different levels through password mechanism as well as various restrictions that we can impose on the access of the data. And when it comes to the data administration, we can have changes in the permissions given to operate on the database, and also fine-tuning of the database. Once a database is built, sometimes we may require maintenance of the data and some fine-tuning of the structure of the logical structure of the database. All these things can be administered very easily on day-to-day basis. Some of the advantages include the crash recovery mechanism. While the database is running, suddenly if the hard disk crash, there is a hard disk crash or a failure, then data should not be lost at any cost. So there should be a mechanism to recover it back. DBMS software provides a variety of mechanisms and techniques and tools to recover the data from the failures. This is another advantage. And concurrent access. Even if thousands of customers or thousands of users, lakhs of users are operating on the database, the DBMS software should keep track of every action of every user. It takes care of that, and whenever there is a crash, it can use the data to recover back. Not only that, to have a control over the mechanisms that operate on the database through users, concurrent or parallel actions, it has a variety of mechanisms can be implemented on DBMS softwares. Similarly, locking protocols are also being used on data to provide concurrent access. Not only that, another advantage is that reduced application development. Though the database is same, we can build several applications, and because of the high-level interface that is being provided to the application developers, they can build a variety of applications on the same database. And the time it takes to build the applications will also is greatly reduced. Quickly, we can build applications over the databases. These are some of the advantages of database management system. So we talk about a software, dedicated software to deal with all these things in the name of DBMS, database management system software.